Alright, so continuing on. Next we have the product rule, which is for taking the derivative of two functions multiplied by each other. So what you might initially think is that the derivative of u times v is just the derivative of u times the derivative of v. You know, it kind of makes sense. It's just like the sum and difference rule. However, I must stress, do not do that. Don't ever take derivatives like that. You'll probably make Mr. Wilson very angry if you do that. Instead, the product rule, or the derivative of two functions multiplied by each other, is so if you have functions u and v, it's the first function times the derivative of the second function plus the second function times the derivative of the first function. It may seem kind of complicated to begin with, but it doesn't. You get used to it. And just to give an example, I guess I'll use the functions x squared plus 4 times x cubed. So using the product rule, we take the first function. So this is our u, and this is our v. So we take our first function, our u. So x squared plus 4 times the derivative of our second function v, which is 3x squared, using the product rule, of course. And then we add the second function, which is x cubed, multiplied by the derivative of the first function, which is 2x plus 0, or just 2x, thanks to the product rule and the sum and difference rule, just to apply what we've learned earlier. So yeah, that's just the basic use of the product rule. And so you may be thinking, if we're just going to use the product rule to take the derivative of polynomials, isn't it just easier to multiply the polynomials together and just take the derivative using sum and difference rule or whatever? That may be true, but sooner you're going to encounter functions like sine of x times x squared, and you have to take the derivative of that. And so you can't just like do something to combine those functions into like something that's not a product, and that's where the product rule becomes necessary. And you'll learn about the derivative of trigonometric functions. And I guess to follow along with the product rule, there's also the quotient rule. So if you have the function u over v, it's not like the sum and difference rule at all. It's more like the product rule. So the derivative of that is the lower function times the derivative of the upper function. Yeah, I just write that. Subtracted by the upper function multiplied by the derivative of the lower function over the lower function squared. Now, quotient rule is really annoying to use, but I guess just practice with it a lot, and yeah, it will become less annoying, I guess. So I guess just to try it out, I'll use the same functions as before for the product rule. This time the derivative of x squared plus 4 over x cubed. So the lower function first, x cubed, times the derivative of the first function, which is 2x, minus the upper function, x squared plus 4, times the derivative of the lower function, 3x squared, over the lower function squared. And there we go. It's kind of annoying to simplify, but unless you're like AP exam, multiple choice, you probably won't ever have to simplify quotient or product rules. I guess just to throw something out there, an easy way, like I guess chant high d low over low squared. So just to write that down. So it's the low function times the derivative of the high function minus the high function times the derivative of the low function over low squared. It's kind of silly, but it kind of helped me remember the quotient rule, so I figured I'd mention it as well. So now that we have all these rules at our disposal, it makes learning the formal definition seem a little bit obsolete, but however, I feel like it's still, the formal definition is really important just so you have a basic understanding of what the derivative is and tying it back to like instantaneous rate of change. And also on the AP exam, they will frequently, on multiple choice, you'll frequently get a question that just tests your knowledge of the formal definition. So it's important just to know and to remember, and just for your sake of your own learning, I guess. So next video I'll probably talk more about specific functions of finding derivatives.